Now it is chapter 12. The chapter is a brief introduction to machine learning. You will see key ideas of machine learning along with mathematical issues and how to solve them. Let's go to the first section. Consider the three tasks. Most real-world problems are expressed as in this equation, f of x equals y. Here, f is an operation or a function. X denotes the input and y is the output. There are three components. Real-world problems are given with two of these three components known, and we need to decide the last one. For example, once f and x are known, then getting y is a simple evaluation. You learned these kind of problems from the elementary school. Secondly, f and y are known, and then you can get x by solving the equation. You learned these kind of problems in the high school and also in the college. Now finally, x, y are known, then you can get f. In reality, the exact function is not easy to get. So we'll try to get an approximation of the operation, which is the core task in machine learning. Machine learning algorithms are algorithms that can learn from data and produce functions or models. Here, xy will be input and output is the function. There are different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is along with labeled data. And usually x is data point, y is the label. And along with xy, we may try to get the function for classification. Now, once no label is given, then the machine learning with those data set is unsupervised learning. So for instance, only the points are given, then by using some clustering techniques, you can make subgroups of the given data set. So basically, from unsupervised learning, we may try to understand the hidden structure of the data set. Reinforcement learning is like in chess engine. An agent will learn a policy which maximizes the reward. So try to get the reward as large as possible. The most popular type of machine learning is supervised learning. Such machine learning algorithms are based on a belief the average is correct, at least acceptable. Consider this a competition. Guess the weight of the ox competition. The questioner is Sir Francis Galton, who is a cousin of Charles Darwin. You may learn about Charles Darwin, who wrote the book on the origin of species, and he claimed the theory of evolution. And Sir Galton was in a county fair in Plymouth, Massachusetts, 1907. He pulled an ox and asked the people the estimated weight of the ox. There were 800 people gathered, and their answer has a mean value 1197. After getting this number, he put the ox on a scale and measured 1198, so that even though the people don't know exact weight, and average value is just simply almost the same, only 1 pound difference. So that average from many input can be correct, at least acceptable. This belief is a base for machine learning. Okay, now we consider supervised learning. The assumption is here, given a data set, X and Y, and here subscript I means the different data point and the corresponding label. So Xi, Yi, and collection of these data points. There exists a relation from X to Y, so we assume a function exists relating X and Y. Now, by using the data, we try to get f hat, which is a good approximation to the assumed function. So that is a supervised learning. We try to find function. Here the data is along with labels, and machine learning algorithm will make a function. Once a function is made, then new data point is coming, then we try to predict. That's the supervised learning. Here, left figure is saying that. Now, here, negative points and positive points. So practically, a function is made like this line, it's a separating line. So that, for example, a point comes here, then now the function may say that this point, new point, is a kind of negative point. So practically, in machine learning, we try to make such kind of a separating line or separating surface and so on. The right figure is a regression. So for given data points, we try to find some tendency of the point. So that looks like here we are matching with the line, because in data acquisition, we may have a noise, but this one is following a line. So regression is a kind of a finding representation. Okay, here we have unsupervised learning. In supervised learning, we know the right answer. That means a label. And when we train our model, and in reinforcement learning, we define a measurable reward for particular actions by the agent. In unsupervised learning, however, we are dealing with unlabeled data or data of unknown structure. Using unsupervised learning algorithms, we can explore the structure of the data set and try to extract some meaningful information. Clustering is an example. Let's see here. And this 3 groups, but the all data points are just a set of data points. And by using clustering algorithm, we found 3 groups like this one, and meaningful subgroups can be detected. That is the clustering. So machine learning algorithms are not so much complicated. Practically, we try to find some separating function so that we can get good classification. But here we have some issues. First one is overfitting, and try to fit the given data points too tightly so that once new data point comes, then it can make some mistakes. For example, here on this figure, and if you try to train the data points too tightly, then you may have this separating curve for 0 points and positive points. Now, once a new point comes here, then looks like a sort of zeros. However, along with this training model, that will be recognized as positive point, so that overfitting will make a huge mistake for new data points. To overcome this issue, you may try to use more trained data. However, this is impossible in most cases because data points is not simply gotten. By paying money, you can get data points, so that more data points is often impossible. And also during the training, because you are using iterative algorithm, you may try to stop the iteration earlier. Then you can do that. Also, try to find some future selection. And also, now you may add some penalty term in terms of regularization. Also, you may try to use multiple classifiers. That is called ensembling. Through these techniques, you can reduce the issues around overfitting. Now, by the way, if you try to get too simple the model, then it's underfitting. For given data set, this is an underfitting, and this is a good compromise. It's right choice. Rather than this overfitting, you may get that one. Now this is underfitting. Okay. The second issue in machine learning is curse of dimensionality. Okay. This one can be explained through this figure. Once the data points are in 1D, then the data points can be accumulated, and then once it has two classes, then now you can see two separate parts quite easily. However, if it goes to 2D, then now, and later on it goes to a 3-dimensional space, then the future space becomes increasingly sparse, and then looks like every point appears equidistant from all the others, so that now classes or accumulated points are not easy to be detected. So that is difficult. So the dimensionality is increasing. Dimension is increasing. Then in machine learning, it's much harder, and possibly accuracy will go down. Larger error, more computation time, and data points appear equidistant from all the others. To overcome this issue, you may need more data points. Again, it's not impossible. It is not possible in most cases. And one more technique is dimensionality reduction through feature selection or feature extraction. Future extraction means that the data set is transformed into another space and then try to select only smaller dimensional component. In this case, you can get better accuracy in many cases. Okay. Now, third issue is multiple local minimum problem. Training is usually requiring sometimes the object function not smooth. Okay. For example, your objective function has some local minima like that. Then if you try to get, okay, this is global minimum, so that's what you have to find. However, your algorithm, iterative algorithm, is like a gradient descent method. It's always going down. So once your initialization is here, then going down and stop here. The same way, and the other side, okay, if you begin with this one, then it's going down here and stays. So that reaching at the global minimum is not easy. So the multiple local minima problem is sometimes quite serious. To overcome this issue, and we may try to get some smoothing of the objective function and also adding some quadratic component through the technique of regularization. And also, if you try to access the data very carefully, as in the mini-patch strategy, then you can overcome this issue a little bit, so that by using such techniques, you can mitigate the issues. Now, the fourth one is interpretability. Although machine learning has come very far, researchers don't know exactly how some algorithms work. For example, like neural networks, we don't understand how they work. If we don't know how training networks actually work, and then we cannot make real progress. So that understanding the algorithm is really a crucial issue. In modern machine learning, the society, most important one is interpretability. In fact, once machine learning algorithms are accurate enough, then interpretability is not an issue. But the algorithms are good enough to say it is accurate. However, it's not really good enough to use for real situations. Sometimes the accuracy must be better than 99%. For example, in finance, in 1% error will make a huge, so that once the money is related, then must be exact. And also, sometimes machine learning algorithms can be used for some criminal investigation. The expected criminal is not really criminal, but machine learning algorithms say that that's the terrorist, then it can be a really big problem. So there's some cases, accuracy is the crucial issue. And because of that, we want to understand the machine learning algorithm. So interpretability is related with accuracy. If you can make really good, accurate algorithm, then interpretability is not a problem. Now, finally, here, issue is around one-shot learning. We say one-shot learning. That means by using only one data point, and the machine learning algorithms learn quite nicely. So typically we say one shot, but anyway, by using a few examples, we try to train the algorithm. Then, because human intelligence can understand through a few examples, but a machine learning algorithm requires many data points. Traditional gradient-descent networks need a huge amount of data and are often in form of extensive iterative training. So it is expensive in data and also in computation. Such traditional algorithms are expensive. Instead, if you can design a neural network so that by using only a few examples, it can be trained well, accurately, then it is really a revolutionary step. So try to consider this issue also. Okay. This is the end of the section. Thank you.